Last video we talked about how to solve a 3 by 3 system of equation. This video we're going to go through applications of a system with 3 equations and 3 unknowns. And so we're going to go through 3 different practice questions that kind of show you how to take a situation, turn it into a system of equation, and then solve that system of equation. So here we have the sum of 3 numbers is 4. Okay, we're going to call one number x, one number y, and one number z. And we know that the sum of these 3 numbers, x plus y plus z, is equal to 4. The first number, x, minus twice the second number, 2y, minus the third, is equal to the number 1. Okay, and that's basically this statement right here converted into an equation. Twice the first number, 2 times x, minus the second number, minus twice the third, so 2 times z, is equal to negative 1. And now that is this statement right here, kind of converted into a mathematical equation. And notice what we're left with here is a system of equation with 3 unknowns. And so now we're just going to solve for x, y, and z, which will allow us to find these numbers. So to solve this system of equations, we're going to do a couple of eliminations. Let's start with the first 2 equations. So I'm going to denote these as equation 1, equation 2, and equation 3. So let's take equation 1 and equation 2 and add them together. And the reason why we're doing this is because it will allow us to cancel out the z term from both of these equations. So let's add these together. So 2x minus y equals, the z's will cancel, 5. And now let's deal with the second and the first and the third equation. I'm going to take the first equation here, and the third equation, and we want to cancel out the z terms. And so notice, to do that, we're going to have to multiply the first equation by a positive 2. So now let's distribute the 2 to both these, or to all 3 of these terms on the left-hand side of the first equation. This is equation 1, equation 3. So now we have 2x plus 2y plus 2z equals 8. And we'll keep this third equation here the same. Okay, now we're in a situation where if we add these together, notice these z terms right here will cancel out like they did this time over here on the left. So 4x, 2y minus y, well, that's going to be plus y, equals 7. And so what we can do is, let's call this equation 4, and this will be equation 5. And we want to use the method of elimination here to cancel out one of the variables from equation 4 and equation 5. And that variable in this case is going to be the variable y. And to do that, luckily, all we need to do is add these together. And so these will cancel. And so we're left with 6x plus 6x is equal to 12. And so the x value here is equal to the number 2. So now we just have to solve for y and z. To do that, we're going to kind of work our way backwards. We can use equation 4 or equation 5 to solve for y. Let's just use equation 5. Doesn't matter, either one will give you the correct answer. So I'm going to take equation 5 here, and I'm going to plug in 2 for x, and then solve for y. So 8 plus y is equal to 7. Therefore, the y value is equal to negative 1. Okay, so we have 2 of our 3 variables, and now we just need one more, the z value, to answer the question. And let's use the original first equation here, up here. So we're going to use this. That one looks like it's the most simple to work with. So x plus y plus z is equal to 4. The sum of three numbers is 4. If we know one of the numbers, x is 2, the second number is minus 1, plus z is equal to 4. Now we just have a simple linear equation that we can use to solve for z. So 1 plus z equals 4. So the z value in this case is 3. And so you can write your answers as like the list of these three numbers, or you can write it as a coordinate point. So let's write it like this. X is 2, y is -1, and then z is 3. And so that's the solution to this application with 3-variable question. Okay, and let's go through a couple more for this video. All right, let's go through a practice problem. So in a triangular cross-section of a roof, so imagine we have a triangular roof and then we kind of slice it in half and look at the cross-section. There's a visual right here. The largest angle is 70 degrees greater than the smallest angle. So let's start by trying to convert this into equations. So we know that if we have a triangle here, x, y, and z will denote the angle measurements. Well, first we know that the sum of each of these angles, regardless of what the values are, is going to be 180 because that's an inherent property of triangles. Let's call z the largest angle, and we'll call x the smallest angle, and then y will be the angle in between. If z is the largest angle, and the largest angle is 70 degrees greater than the smallest angle, then the largest angle z, if it's 70 degrees larger than the smallest angle x, can be defined as x plus 70. So that's our second equation. And then the largest angle z is twice as large as the remaining angle. We're going to call that y. So the largest angle z is equal to 2 times the y value. Okay, so now we have a system of equations here, which we're going to use to solve for x, y, and z, and that will give us the angle measurements of this triangle. So we have 3 equations. Before we try to solve this though, if you remember from the last video, the first step is we want to take this system of equation, we want to write this in standard form. Let me just open this up so it doesn't happen again. So if I want to write this in standard form, we basically want to take all of the variables and bring them to the left-hand side, and all of the constants and move them to the right-hand side. And so the first equation here is already in standard form, and so we'll just leave that alone. The second equation is not in standard form because the x and the z are separated from one another. So what I'll do is, let's keep the x positive, but I'm going to move the z to the right-hand side, and then I'm going to move the 70 to the left-hand side, which is going to change the sign of the z and the 70. So equation number 2 is equivalent to x. I'll leave this part blank. Minus z is equal to -70. So that's equation number 2. And then equation 3, let's move the 2y over. So we have, well, the x part's blank, minus 2y plus z is equal to 0. This is our third equation in standard form. Okay, so now we have a system of equation written in standard form. Let's use elimination to solve or to get rid of one of the variables. I think z is probably the easiest variable to get rid of. I'm going to start by taking the first equation and the second equation, and then let's get rid of z by adding those together. So x plus y plus z equals 180. x, I'll put the zeros in this time, 0 minus z equals negative 70. And let's add these together. If we add these together, 2x plus y, the z terms here will cancel out. And so we've eliminated that variable. And the constant on the right-hand side is going to be 110 in this case. Okay, now let's add the second equation and then the third equation together. So x plus 0 minus z is equal to 70. This is a z right here. And then negative 2y plus z is equal to 0. And now let's add these together. Well, the x will be by itself. The minus 2y is still there by itself. And then the z's cancel out again. Is equal to, should be a negative 70. Negative 70. And what we can do is denote this as equation 4. And we'll call this equation 5 over here. And let's add these together. So equation 4 plus equation 5 we get 3x. Well, what we need to do, is actually, we can't just add these together. We actually need to multiply the second equation by the number 2. Let's actually multiply the first equation here by number 2, because if we notice the signs are the opposite for the y terms. So we're going to multiply this equation by 2, and we end up with 4 times x plus 2 times y equals 220. And x minus 2y, this will stay the same, is equal to negative 70. So it's just a little bit, I mean, you can multiply the second equation here by negative 2, but I think the arithmetic's easier if we just multiply the first equation by positive 2. And so in this case, we end up with 5x, well, the y's will cancel, is equal to 150, and so the x value is 150 divided by 5 is going to be 30. And so now we're going to plug this into either equation 4 or equation 5 to solve for y. I think equation 4 looks a little bit easier. So let's plug 30 in for x. So 60 plus y equals 110. Y is equal to 50. So we have our second angle, and then we just need that last angle. Well, we know the sum of the angles is going to be 180, so we'll just use that first equation. Actually, what we can do is, this might be a little bit easier. If we go to the top here, this might be the easiest equation to use with the least amount of arithmetic, because all we need to do is to get z is just take the y value and multiply it by 2. And so z is equal to twice the y value, and so z is going to be equal to 100 in this case. So we have 30 as our x value, our y value is 50, and then the largest angle, these are all degrees, is 100, and this is our answer for practice problem set. All right, we're going to wrap up this video by going through problem set number 1. We're going to cover one more of these application questions. So Caitlin frequently downloads music, TV shows, and movies. And so over the course of 3 months, January, February, and March, she downloads a certain amount of each of these kind of programs. So let's call songs the variable s. TV we'll denote as the variable t. TV shows. And then movies will be the variable m. And our goal here is to find the price of each of these programs when she downloads them. And so we know that in January, she spends $195, or 55 on 5 songs, 10 TV shows, and 3 movies. So 5 songs plus 10 TV shows plus 3 movies equals $55. So that's the first month. Second month, February. She spends $195 on 25. So this is the second month here. So $195 on 25 songs plus 25 TV shows plus 12 movies equals $195. And then lastly is the month of March. Here, that's $81 on 15 songs, 8 TV shows, and 5 movies. Okay, and our goal here is to solve for each variable, and in doing that, that will give us the price of each of these programs. So, this is a 3x3 system of equation. So let's start by eliminating one of the variables. I think the easiest variable to eliminate here is going to be the variable s, because all of these are easy multiples of one another. So let's start by taking the first equation and the second equation, and we're going to multiply the first equation by -5. Okay, I'll skip a couple steps and just do that first arithmetic. So -25s minus 50t minus 15m is equal to 55 times -5, which is -275. And we're going to add to that equation number 2. So it's 25s plus 25t plus 12 times m equals 195. And let's add these together. So we end up with -25t. This is going to be minus 3m equals -80. So that's one equation with 2 unknowns. Let's get the second equation with 2 unknowns. And we're going to take the second equation, or sorry, the first equation and the third equation and multiply the first equation by -3. So again, we're going to be eliminating that s term. So -3 times, we're going to multiply -3 by this whole equation here. So -15 times s minus 30 times t minus 9 times m equals -165. And we're going to add to that the third equation. We're just going to leave the third equation alone. All right, so in this case, the s's will cancel again. And we're left with -30 plus 8, -22 times t, minus 4 times m is equal to -84. Okay, so now we have our 2 equations with 2 unknowns. We're going to have to do a little bit of arithmetic here. Let's try to get rid of the m's by multiplying one of the equations by 3 and the other one by -4. So we're going to take the first equation here. Let's multiply this equation by 3. So -22 times t minus 4 times m is equal to -84. And then we're going to multiply the second equation by -4 because we want these signs to be opposite. Okay, now let's multiply this through. So -66 times t minus 12 times m is equal to -252. 100 times t plus 12 times m is equal to 320. And now we're in a place where we can add these together and get rid of the variable m. So -66 plus 100 is 34 times t is equal to 68. And so the t value here is going to be equal to 2. Okay, now we're going to plug this t value into either this equation or this equation to solve for m. Let's just plug it into the left-hand side. It doesn't matter which one you plug it into, you get the same answer. So negative 25 times 2 minus 3 times m is equal to negative 80. This becomes negative 50 minus 3m is equal to negative 80. Let's add 50 on both sides, so negative 3m is equal to negative 30, and so the m value is equal to 10. And then lastly, we're just going to use one of the original equations to solve for s. And I think the first one's probably the easiest, so I'm just going to scroll up so you can see it. This one, again, is probably going to be the easiest one to use. So let's plug t and m into that first equation. So 5 times s. My 5's and s's look very similar. So 5 times s plus 10 times 2 plus 3 times 10 is equal to 55. So 5 times s plus 20 plus 30 is equal to 55. 5 times s plus 50 is equal to 55. 5 times s is equal to 5. And so s is going to be equal to 1. Okay? So that will give us our answer now. So the price of one song to download is $1. The price of one TV show to download is $2. And then the price of one movie to download is $10. That's the answer for this question.